Hi, my name is Michael Barris, and I'm a Principal Solutions Architect on the RDS Oracle Database Engineering team. Thanks for joining me while we take a quick look at what the RDS Oracle team has delivered over the last year. I'm going to cover three major areas: Oracle features and versions, disaster recovery with RDS Oracle, and improvements we've made for managing your Oracle instances. First, let's take a look at Oracle features. This year, Oracle changed their licensing to make the spatial and graph option available in all editions for free. So we've updated our option groups to reflect that, and you can now add the spatial option to standard edition instances. Of course, it's still available to Enterprise Edition customers who no longer need to purchase an extra cost license to use it. Oracle has not published any deprecation information for the Locator option, but since spatial contains all of the features included in Locator and is now free, we do recommend sticking with spatial going forward if you have those use cases. We've also added support for Oracle's Online Analytical Processing, or OLAP, which does remain an extra cost license on top of Enterprise Edition. Keep in mind that options like spatial and OLAP require that the Oracle Java Virtual Machine be installed inside the database. Each quarter, Oracle's critical patch updates address high security vulnerabilities in OJVM, so we do require customers to enable automatic minor version upgrades when these options are installed. This does require a brief outage each quarter, but ensures that you're running the latest critical fixes. Because of that, we recommend against installing any of the OJVM-related options unless you know you need that functionality. Amazon RDS remains a popular place to run Oracle's Application Express development platform, and we're continuing to keep that up to date. We've added support for Apex 19.2 and 20.1 this year, and we'll continue to keep up to date as new versions become available. Finally, for government customers and those with regulated workloads, we've added support for FIPS 140-2 SSL parameters, and we continue to make critical patch updates available shortly after Oracle's release each quarter. Now, last year we announced that we'd be deprecating Oracle Database 11.204, and that work is almost done. Bring your own license customers still have until the end of the year, but we strongly recommend against waiting. It's super important that all major version upgrades be carefully tested. As a managed service, we have to make sure that our customers are able to address any critical vulnerabilities. That means we can only support versions for which Oracle is providing patches and updates, which finally ends on December 31st of this year for 11.204. The next deprecation coming up is 18C in June of 2021, so customers should hopefully be planning for that already. For 12.1, Oracle has given customers a bit more time, with support now ending in 2022. But keep in mind that bring your own license customers do need to have extended support or upgrade to a version covered by their premier support. Oracle has changed some of the dates for 12.1 and 12.2, so we'll continue to keep an eye on those and adjust accordingly. But we do recommend that all customers make their way to 19C, as this is the terminal patch set for the 12.2 family. This has been designated a long-term support release, with standard support available through at least 2024 and extended support available through 2027. We'll keep our AWS forum post updated as any dates change, so make sure to keep that bookmarked. And make sure to keep an eye out for any email or personal health dashboard updates regarding your instance. Now let's talk about disaster recovery. First, some terminology. High availability and disaster recovery offer similar protections, but can be two very different use cases. With a managed service like RDS, high availability is a feature. Just turn it on and you've got high availability. This works within a region. We can take advantage of multiple availability zones that are close enough together to allow for synchronous replication, which means we can automate failover without worrying about data loss. You still need to test to make sure your application can handle failovers, but for most customers, it just works. While we offer features that support disaster recovery, it's best to think of disaster recovery as policies and procedures. It's something you do, not just something you turn on. If your database encounters a situation that high availability can't cover, there may be a different path to recovery depending on how quickly or with how much data loss you can get back up and running. Customers generally choose a multi-region strategy here, but just about any DR strategy is asynchronous. This means that activating it will involve some amount of data loss, at least in the short term, so this is always a decision you have to make carefully. Disasters happen when you least expect them, so it's important to really understand what your requirements are, have a plan for how to get back up and running, and test that plan carefully. 3 a.m. is a bad time to find out that you don't have the right privileges to restore backups or haven't gone through all the steps of restoring your production instance. Now that we're clear on what disaster recovery really means, let's look at 3 features that RDS has launched and improved this year that can be a part of your disaster recovery strategy. We continue to improve read replicas, we've launched the ability to support mount mode replicas, and we've extended our automated backups to support cross-region use cases. First, read replicas. With a few clicks in the console or a call to the Create DB Instance Read Replica API, RDS automatically creates a replica of your primary instance and keeps it up to date. Replicas are built on Oracle DataGuard physical standby databases, so they do require Enterprise Edition. And read replicas also require the additional cost Active DataGuard license on top of Enterprise Edition, both for the source instance as well as any replicas. Each read replica is a physical standby database running in maximum performance mode and open for read-only access. We also create a dedicated encrypted tunnel between the primary and each replica, so replication traffic is always encrypted, independent of what options you've configured for session-level network encryption. Each primary supports up to 5 replicas, and they can be a mixture of in-region and cross-region. RDS manages the DataGuard configuration, so you don't have to worry about configuring DataGuard broker, troubleshooting replication failures, dealing with gaps, or any of the other heavy lifting involved in managing DataGuard yourself. It is possible for replicas to fall behind if your workload is more than they can keep up with, so it's important to verify that your configuration can support your peak workload. Replication lag is published to Amazon CloudWatch as a metric, so you can monitor it and create alarms to let you know if action needs to be taken. Read replicas enable a few different use cases, but the biggest are read scaling and disaster recovery. They don't support synchronous replication or automated role transition, so we still recommend the multi-AZ feature for high availability use cases. Suppose my instance here always needs to be up and running and can only tolerate a few minutes of outage each month. For high availability, I should enable the multi-AZ feature, which creates a synchronous replica in another availability zone that's just a millisecond or so away. If the primary instance becomes unavailable, RDS automatically detects that and fails over. RDS takes care of repairing the old primary and getting the configuration back into high availability. Now, perhaps my application has significantly more reads than writes. For this use case, I can create a read replica, and RDS will fully manage the asynchronous Active DataGuard configuration. Now, this replica is serving my application traffic, so its availability is also important to me. So I can enable multi-AZ here as well. Now, if the replica becomes unavailable, RDS automatically fails it over to infrastructure in a secondary availability zone. RDS automatically takes care of resuming DataGuard replication and resolving gaps after failover of either the source instance or the replica. I can also create additional read replicas based on my particular requirements. They can be in the same availability zone as the source instance, different availability zones, or even different regions. Again, I can create up to 5 total replicas for each source instance. Finally, replicas can also be sized differently than their source instances. Suppose my source instance is running on db.r5.8 extra large instance sizes. Multi-AZ uses a symmetric configuration, so the synchronous secondary will also be that same instance type. But maybe my read replica doesn't get quite as much traffic this time of year, so I can run it as a 4 extra large. The same will be the case with its multi-AZ secondary. Or suppose one of my replicas is used primarily as a data warehouse, and I want a lot of storage bandwidth for full table scans, so I create that as a 16 extra large. When sizing replicas, it's important to make sure that the replica is at least strong enough to keep up with the replication traffic and workload you throw at it, or replication may fall behind. As you can see, read replicas can fit together to support a variety of configurations depending on your requirements, and they work with, not in place of, multi-AZ for high availability. Replicas can also satisfy many disaster recovery use cases. This is more common as a cross-region solution, but works in region as well. When you promote a read replica using the console or promote read replica API, RDS stops replication, converts the database from a physical standby to a primary, and opens it for read-write access with its own listener endpoint. In Oracle terms, this is called activating the standby. At this point, it is completely separated from its old source instance and other replicas. After an instance has been promoted, you can then use it as a source instance for creating new read replicas. While this is not a traditional role transition for DataGuard, it can still get you back up and running with very little data or time lost. And depending on what caused the source instance to fail, you can often recover unreplicated transactions once the original source instance is back up and manually integrate the data into your new primary database. Obviously, that's something that you'll want to test. The second disaster recovery feature I want to talk about is mounted replicas. Replicas can now be configured to run in read-only mode or in mounted mode. This is great for customers who want the disaster recovery functionality of replicas, but don't have read scaling use cases or don't have the additional cost licenses required by the active DataGuard option. Like read replicas, mounted replicas are fully managed Oracle DataGuard physical standby databases. They can be promoted to read-write databases and can be included in the mix of up to 5 total replicas for each source database. Because mounted replicas are not open for read-only access, they only require Oracle Database Enterprise Edition licensing. You can set up the replica mode when you create the instance, and you could change it later using the Modify DB Instance API. But do remember, if you switch from mounted to read-only mode, you do need to have the necessary active DataGuard licenses in place. The third disaster recovery feature is an improvement to our automated backups. Backups are an important part of any availability strategy. Over the long term, they preserve the state of your database at particular points in time. In the short term, they provide a continuous change-by-change record of activity that lets you go back to a specific moment in your transaction history. With RDS, just set the backup retention period to 1 or more days, and the service takes care of everything else. When you enable automated backups, RDS automatically takes a daily storage level snapshot of your instance. This happens in a backup window, which you can choose, but defaults to the nighttime for your region. We also place the database in archive log mode and make sure that the online redo log is switched at least every 5 minutes, so that archive redo logs can be backed up to Amazon S3. You can even view the latest restorable time for your instance in the console or through one of our Describe APIs. This represents the time to which you could recover if your database were to suddenly become completely unavailable at that moment, and should typically stay within the last 5 minutes. And RDS automatically takes care of cleaning up your old automated backups based on the retention period you specify, which can be 1 to 35 days. Restores with RDS always create a new instance based on your restore criteria. This new instance will have its own endpoint name and can even have different instance type or storage type than the original instance. You can change instance identifiers, which changes the endpoint name in DNS. So in a production recovery scenario, you can swap names without having to delete the original instance. When restoring from backup, you really have 2 choices here. First and simplest, you can restore a snapshot. This creates a new instance with the same data as the source instance as of the moment the snapshot was initiated. Snapshots can also be copied to other regions and other accounts before being restored. Snapshots can even be upgraded. With the snapshot upgrade feature, we'll restore a snapshot offline, upgrade the version of Oracle database that it contains, then take a new snapshot to replace the old one. The second restore option is point-in-time restore to any second in your automated backup retention period. You can specify the exact restore time you want, or choose latest restore time to restore to the latest redo log that's been backed up to S3. RDS creates a new instance based on the closest snapshot to your restore time, then uses Oracle Recovery Manager to apply archived redo logs, rolling forward to the specified time. The amount of time to perform point-in-time restore is longer than snapshot restore, and depends primarily on how much redo needs to be applied. One way to reduce this time is to augment the automated daily snapshots with manual snapshots throughout the day, which you can automate using services like AWS Lambda or AWS Backup. For example, taking 6 snapshots a day ensures that a point-in-time restore scenario would need to apply at most 4 hours of redo logs. While snapshots can be copied across regions, point-in-time restore has only been available in region. We heard from a lot of customers who needed the ability to recover from disasters across the globe with minimal data loss, so that's something that we've addressed this year. With cross-region automated backups, RDS automatically copies your snapshots and redo logs to a second region. As new snapshots and redo logs are backed up on the primary, they're sent to the second region. And as your oldest backups are automatically deleted based on retention in the source region, as well as in the second region, which can have its own retention period. This means that now you can easily restore snapshots or perform point-in-time restore in a second region. With cross-region automated backups, you can now achieve recovery objectives across regions that are close to what you can get in region. This is great for customers who have disaster recovery requirements, but can't justify additional infrastructure or license costs of running standby databases. The second region supports its own retention, so for example, you could have 30 days of backups in region and only keep the last 5 days in the recovery region. Latest restore times will be a bit longer since it takes more time to ship and verify everything across regions, but the APIs have been updated so you can monitor both the in-region and cross-region latest restore times. Now that we've talked about a few different disaster recovery features, let's brush up on some terminology in order to compare them. Recovery Point Objective, or RPO, describes how much data loss your workload can tolerate during a disaster. The older the backup you restore to, the greater the data loss, so your strategy needs to be designed to accommodate your RPO. If your RPO is 1 hour, then copying a snapshot to another region once a day probably won't cut it. The smaller this number, the more frequent your backups need to be. Recovery Time Objective, or RTO, indicates how long you can afford to be down before getting your service back up and running. If your RTO is 1 hour, and it takes 2 hours to perform a point-in-time restore, then you'll need a different strategy. In this table, we can use RPO and RTO to compare how these features work. So as we go down the rows, RPO and RTO shrink, and costs increase. Snapshot Restore is suitable for many workloads that can tolerate a few hours of data loss in a disaster. Because logs don't have to be replayed, restore time is usually pretty quick. Point-in-time restore adds backup storage costs as well as network costs for cross-region, but can greatly reduce RPO. Because redo logs do have to be replayed, restores can take several hours for heavier workloads, especially if snapshots are only taken daily. So backup-based recovery may not meet stricter recovery time objectives, but this is something you can test for your particular workload. For Enterprise Edition customers, replicas provide hot capacity that's nearly caught up with the primary and can be promoted in just a few minutes. These replicas require additional costs for licensing and infrastructure, and for read replicas require active data guard licenses, but they enable tighter recovery objectives than what can be achieved with backups alone. Like I said before, disaster recovery is about planning and processes. Disasters come in all shapes and sizes, so it's important to know ahead of time what your options are for getting back up and running. Start by defining your requirements. Find out who owns these for each of your applications, challenge whether the objectives are really reasonable, and understand what's required to meet them. Next, design your resources based on your requirements. If you truly have an RTO of 5 minutes, then you'll need to account for replicas in your design and budgeting. Make sure to carefully plan out the commands and processes for common recovery scenarios. Just turning on features isn't enough here. Do your nighttime operators have the right privileges to get a restore rolling? If you need to restore into another region, do you have the right VPCs, application servers, load balancers, and whatever else you need? Finally, test. Test, test, test. If your runbook has incorrect restore commands, it's better to find that out during a DR game day than have to scramble or make mistakes when it matters most. New RDS features like read replicas, mounted replicas, and cross-region automated backups are helpful tools, but careful planning and testing are key to getting you to your objectives. Finally, let's look at some manageability improvements we've launched this year. AWS License Manager lets you track your commercial software licenses across AWS services at no additional cost. With this service, you can create license configurations that track your usage by Oracle additions or features, And License Manager will automatically monitor your RDS instances and report how many vCPUs are being used by each license configuration. With RDS Oracle, hard limits are not supported, so it won't prevent an instance from being created. And License Manager can track options and packs that are explicitly enabled via RDS APIs, but doesn't monitor your in-database feature utilization. For example, it can monitor active data guard licenses based on read replicas you've provisioned, and it can track OLAP licenses based on your RDS option groups. But it doesn't track whether you've used the partitioning or advanced compression options inside your database. You're still responsible for ensuring proper licensing and use, but License Manager can help simplify some of that work. We've also added 2 new packages to the RDS admin schema inside your RDS Oracle instance to help manage diagnostic tasks. Many customers who have licensed the diagnostic and tuning packs are accustomed to generating AWR reports using SQL scripts or Oracle Enterprise Manager. While both of those still work fine with RDS Oracle, the new RDS admin diagnostic util package provides a simple interface that lets you quickly generate ASH, AWR, and ADDM reports. The reports can be copied to S3, viewed using PL SQL inside the database, or downloaded from the AWS console. We've also added a new package to provide an interface to Oracle's automatic diagnostic repository. Use this package to view information about crashes and failures in your database and generate diagnostic packs to send to Oracle support. Let's look at an example. Here I've run a SQL command in my database that has caused my session to terminate unexpectedly. This usually indicates a server process crash or core dump due to an internal error like Aura 600 or Aura 7445. I can use the RDS file util package to query my text alert log, and sure enough, I see an Aura 7445 was reported. I can also use the AWS console to view and even tail my alert log and see the same information. Using the RDS admin ADRCI util package, I can list ADR incidents and problems. Here, list ADRCI problems reveals the same Aura 7445 I saw in the alert log. The create ADRCI package procedure gathers up relevant incident, trace, and log files into a single zip archive. Note that these packages use an asynchronous task model. The package command returns a task ID and then performs its work in the background. Use the task ID to monitor the related log file to see the output of the procedure and monitor its progress. Once the package is created, I can go to the AWS console, search for zip files, and download the file so I can forward it along to Oracle support. So that's a quick overview of new RDS Oracle features we've launched this year. We've expanded availability of Oracle Spatial, added support for the latest Apex versions, and done the hard work of deprecating 11.204. New disaster recovery features help you meet your recovery objectives, and new database packages and License Manager integration give you more tools to manage your instances. Learn more about these features by visiting aws.amazon.com/rds/oracle. Find detailed documentation, papers, and customer case studies, and helpful videos and blog posts. But there's really no substitute for testing it out yourself. See how easy it is to spin up an instance and test your particular use case. And here are some specific resources that can help you on your journey. You can use the Getting Started guide to create your first instance, cut through the complexities of Oracle licensing with a blog post by our partner House of Brick, read up on how the role of the DBA changes when you move to managed databases, see best practices for upgrading to Oracle 19c on RDS Oracle, learn how read replicas can help support your read scaling and disaster recovery use cases, and let Cathay Pacific Airways tell you how they improve both performance and security by moving to RDS Oracle. Finally, make sure to check out our other RDS sessions at reInvent this year. .202, .208, and .216 have useful information for RDS in general, RDS SQL Server, and migrations on RDS. Thanks for spending this time with me, and have a super day.